Hey TechKnowStuds! In this lesson, we're going to start laying the foundation for the octal numbering system. We're going to compare it to decimal and binary and hexadecimal and see what some of the differences look like. We'll do a few calculations in here, but really it's just to get an understanding of what the octal system looks like. Oct means 8. And so think of like an octopus, which has 8 tentacles. So octal is 8. So we're using a base 8 system here. So we have a 1s column, an 8s, a 64, 512, and 4096. So what does this look like when we're counting? Well, we'd start out at 0, 1, 2, 3, 4, 5, 6, 7. And then when we get to 7, this is where we reset this column because we are only counting up to 8. And then we bring that over to the next column. So now we have 1, 8 and 0, 1s here. And then we can continue to count out. So 1, 1, 2, 1, 3, and so on and so forth. So it's just like the other numbering systems, except for across the top here, we have 1, 8, 64, 5, 12, and 4096. So how would we actually calculate a number in here? I'm going to briefly go over just from a high level because quite frankly, you're really not going to be using these numbers like this. I just want you to have an understanding of how this relates, octal relates to something like hexadecimal or binary. So what you can look at it as is how many 512s we have? Well, we have 2, so that's 2 times 512. How many 64s do we have? Well, that's 6, so we have 6 times 64, and you would add these together. How many 8s do we have? We have 4, so 4 times 8. How many 1s do we have? 3, so that's 3 times 1. We add all these together, and that's how you come up with whatever answer is here. So that's a real quick overview, but like I say, you wouldn't really use this too much. This is not how we really use the octal systems, but this is how it relates to our binary or hexadecimal numbers. Because remember, the binary numbers, what we have is how many 1s there are, how many 2s, how many 4s, how many 8s, even though it's just represented by a 1 or 0 for each of those. And from the hexadecimal, we went over the same thing. We had 4096 times 4 to come up with that. So that is the hexadecimal system. So it's all pretty much the same, except for we're just using a base 8 rather than this case, it's a base 16, or in the other case, with binary, it's a base 2. So if we actually wanted to go through this, we could say 512 times 2 equals, and that's 1024 right there, so 1024. And then we have a 6 times 64, so 6 times 64, and that is 384. So there's 384. And then we have 4 times 8, so 4 times 8, which is 32. So we've got a 32 there, and 3 times 1, which is just 3. So now we can add those together. So 32 plus 3 plus 384 plus 1024. And so what we come up with this is 1,443. 1,443. So that's how you would actually do that conversion for that.